One thing I'm always a bit critical, but also I'm also hopeful, is about potential applications of hyperspectral data. Now, really, if you think about an operational setting, I mean, in forestry, foresters are interested in certain things. And for example, one thing for sure is species information that they're interested, the health state of a tree, of a forest stand they're interested. But then we always say there's a lot of potential for hyperspectral data to deliver these things. What is your opinion on that? Do you really think that, I don't know, let's say in 15 years from here, we will have species information from hyperspectral data for the whole of Germany?
I'm quite hopeful, and this has several reasons. One is that we're still not at the end of the technological development. I still think there is some potential in having narrower bands and having a higher spatial resolution. And at the same time, I know there will be hyperspectral mappers. At the moment, we just have magnifier classes, very small images from satellites or drones. But with GEIM and SPG, we will have in the future real, let's say, maps for the whole of Germany. And then we will have the chance to differentiate much more, as we do with multispectral scanners right at the moment already.
But how do you see it? Like, if I think now about the trend in Central Europe, I mean, now this is a very narrow perspective, but still, we're moving towards more and more mixed forests. And these mappers that we are talking about at the moment, again, spatial resolution, we have 30-meter pixel sizes. And 30 by 30 meter areas, we have been like scanning a lot of 30 by 30 meter pixels lately with terrestrial laser scanning. So there are a lot of trees in 30 by 30 meters, depending maybe also on the stat, but still a lot of trees can fit in this area. So would you then just say we go for unmixing? I hate unmixing. I don't believe in unmixing. But what do you say? Like, what would be the solution to that?
Which is funny, because I did studies in unmixing and still think unmixing is working quite well. Unmixing means that we have a very coarse resolution pixel, and we try to find certain parts of it which are pure. So if we have 30% of forest in a pixel, then we can find this out via unmixing. There might be some videos on that as well.
Yes, but would you say, I agree, you can unmix forest from asphalt and water. I agree with that. But can you unmix the percentage of beech from an oak stand? Do you believe in that? I mean, would this be that in the future?
I don't think that's possible, because these spectral signatures are really, really very close to each other. I think you can differentiate an oak leaf from a beech leaf from the spectral properties, but not in the mixture. And then it is really complicated, and we need there are two ways, either you find ways to integrate other information, like LiDAR information together with hyperspectral information, or you find a way to have a higher spatial resolution, which seems not to be likely right at the moment, because even the future planned missions are all 30 meters. So, but perhaps there might be still the possibility, perhaps if we have sensors which are just visible in V-near without the shortwave infrared, it might be easier to have a, let's say, 5-meter resolution pixel hyperspectral from a satellite, and this might be the solution.
Yeah. Okay, I will ask it again, like in a very direct way. So, do you think for really mapping species operationally, like the main tree species that we have in Central Europe, will we use hyperspectral data for this, or will it rather be a combination of Sentinel-2 time series plus orthophotos with like very high resolution combination? If I don't know, CNNs, like deep learning algorithms, they can really make use of this information. So if we have this package, do we need hyperspectral?
I still think there is something missing. And there is something missing about the pigments, about the properties, about what is in chemistry in the trees. Because in the end, hyperspectral remote sensing is like chemistry from space. And this is missing if you just look at structure, you look at time with Sentinel-2, you look at structure with orthophotos, but you still miss the chemical properties of the species. And I don't say it's impossible to do it with orthophotos, deep learning, and Sentinel-2, but it's definitely better with hyperspectral.